Welcome everybody. My name is Aikaterini Tavri. I am a PhD candidate at the University of Victoria in Canada, and I'm going to present my work on C-band, fully polarimetric and simulated compact polarimetric synthetic aperture radar data for sea ice type separability during the seasonal advanced melt period. Sea ice mapping using synthetic aperture radars is well established during the winter when the ice type signatures are distinct. Plethora of classification algorithms utilize polarimetric properties for classifying first-year and multi-year ice. However, as the summer melt progresses, the presence of melt ponds transforms the sea ice surface and its scattering properties. Especially during the advanced melt period, the backscatter signature of first-year and multi-year ice types is mixed, limiting the classification potential. By examining different polarization configurations, we are able to retrieve detailed information about the scattering processes. Fully polarimetric systems offer higher information content per pixel, but their capabilities are limited in spatial coverage. Compact polarimetric systems can provide similar information content, and they have the capacity to cover up to 500 km swaths on the ground. Both systems record complex information related to target properties that are useful for optimized sea ice type separability measures. For this research, an optimal set of compact polarimetric parameters is determined for first-year and multi-year ice separability during advanced melt period. These parameters, together with corresponding fully polarimetric parameters, are being fed into a neural network for determining classification potential of both systems. Radars at two scenes were acquired over McClintock Channel and Deep Strait in the Canadian Arctic archipelago. Data from over 3 years have been analyzed together with ancillary datasets from other microwave and optical sensors, as well as weather station and ice chart data to understand the sea ice conditions. For this analysis, we focus on results from 2018. Two main processing chains were followed. The fully polarimetric images were processed for retrieving the H-alpha decomposition, as well as other polarimetric parameters, for evaluating the first-year multi-year ice separabilities. The same dataset was then simulated to compact polarimetric configuration, and 32 polarimetric parameters were calculated. By evaluating parameter correlation and separabilities, only the top 3 of its configuration was used as an input for a neural network classification algorithm. External data were processed for seasonal attribution. For 2018, the melt onset, which is signified as the point where the first-year and multi-year ice backscatter signatures are met, was on the 10th of June, based on the ASCA time series from that year. After the melt onset, we observe a steady increase on surface temperature, leading to a strong variability of the backscatter signal. There is a period in the advanced melt where the first-year and multi-year ice signatures are reversed, but overall we see that there is a strong mixture in the backscatter signals for both sea ice types. By comparing the Kolmogorov-Smirnov separability analysis for both configurations, they present larger differences between sea ice type backscatter during the melt onset and the early advanced melt period. Once the melt ponds are formed, data acquired under steep incidence angle support better separability for first-year and multi-year ice signatures. Here, the evolution from melt onset to advanced melt regime is shown only by one parameter for its configuration, and this is because the parameters were selected as they were defined in similar ways and they can be representative. The results of the neural net classification are of moderate accuracy for both configurations. This is due to the low separability measured for that specific date. Nonetheless, compact polarimetric parameters show potential similar to the one of fully polarimetric. This supports the use of this data for improving sea ice mapping during advanced melt conditions. Based on the correlation and separability analysis, these 3 compact polarimetric parameters presented similar classification performance with the fully polarimetric parameters. Overall, there is still more analysis required for robust conclusions between the 2 configurations' potential for advanced melt ice classification, and in the future steps is to examine more algorithms and present more results from different years. Thank you so much for your attention.